Good morning all. Today I've got some new PCBs from JLCPCB, so let's take a look inside the box. And there's a free gift, and it is Smile to Everything. I think this is insulation tape. Yes, it does appear to be black insulation tape. Cool. Right, circuit boards are here, and they are these. So I've got 5 pieces of this board. I think that meant that it was the minimum $2 price. Now I might use all 5. I could use all 5. In fact, I can decide how many I use. So this is the Tom drum synth. So what this does is it synthesizes, using lovely analog electronics, the sound of a tom-tom drum. And of course, if I build all 5 of these, I can go do-do-do-do-do-do-do-do-do, that sort of thing. So this design comes from an electronics magazine. It was kind of electronics and music, and so drum synthesizers, analog drum synthesizers, were all the rage back then. Now this was nearly 40 years ago. I think the article was 1981. So these are analog chips. I think that's a 741. It just amplifies up the level from, well, a piezo sounder, which is used in reverse, used as a microphone. So you tap the piezo, it generates little pulses, and they're amplified, and that's used as a trigger. This is a quad op amp. Now they used a funny one, something like a 3403, but I'm going to use an LM324 because that's commonly available. And then this chip here is a CA3080, which is a transconductance op amp. Now I've used those before in the vocoder, so I should have some of those. There are a couple of capacitors, but not many. One to set the sort of tone, the doo tone, and of course the simulation here is that the tone falls in pitch. So it goes doo doo, and that's because when you hit the skin of a drum, I can use this, a conventional drum, as it vibrates to its maximum extent, of course the skin is pulled tighter and therefore it's a higher pitch. As it starts to reduce in movement, that pitch falls. It's only very slight, it's doo, that sort of thing. But of course, when these analog drum synths were designed back in the 1980s, the very extreme doo sort of sound became very popular and started to be used in all sorts of music. Here's the schematic I did in Easy EDA. It's difficult to see exactly what's going on here because that's the quad op amp. But you can see that there are 4 op amps with lots and lots of resistors around them, and the odd capacitor for generating the tone. Lots of pots here. We've got a sweep pot, a pitch pot, a decay pot. How quickly does it decay? And there's a volume pot on the output. Here's a 741. You can see it's got a 1 meg feedback resistor, so it's high gain. That's amplifying the signal from the piezo transducer to generate a pulse which charges this cap, and then this 1 meg pot makes the cap voltage decay. And there's the transconductance op amp. Its control voltage is here, which comes through this 4K7, is it? From over here, which is the output, I think, of the first stage of all the op amps. So that controls the VCA, the voltage controlled amplifier. That's what causes the decay in amplitude. So as well as dropping in pitch, doo, it drops off in amplitude as well. So let's get building, I think. So I'm actually going to start with the 2 diodes, 1N4148. I think on the original circuit they were 1N914s, but it doesn't really matter. Because these are the lowest profile components, I'll shove them in first, and then I'll dig out all the resistors, and there are quite a lot of resistors. So the 2 diodes are in the board. All I need to do now is glue them in. And when I say glue, I do of course mean solder, not literally glue them in. Let's solder them in. Have I cleaned my iron? I don't think I have. I haven't used it for a while actually. So let's get these two 4148 diodes on the board. And then I might just get all the resistors and solder them all in one go, because there are lots. In terms of resistors, I don't think there's anything really very exotic. There's bound to be 100k. I'm going to need 47k's, possibly 22k's. I'll get all the boxes off here of the values that I'm bound to need. There are no 220 ohm resistors. This was all sort of laid out for the vocoder project. Did that project really have no 220 ohm resistors? I'll have to find some. So on this one, I didn't go to the trouble of putting in the component values. I've got the component numbers, but of course my schematic gives me the cross references between value and component number. And the other thing I did on this one is I made every component on here exactly the same component number as the original magazine article, so I can always refer back to that and there won't be any discrepancies. I didn't do that with a vocoder and it was a real pain. I've put a ring around these components which are all 100k. Let's get all the 100k's in. I'll go by the numbers. So while I put these in, 5, 7, 8 and 9, I've got a favour to ask you. JLCPCB are running a competition and myself and a number of other electronics YouTubers are in this competition, and I'd like to win, or at least I'd like to be reasonably near the top. And unfortunately, I'm lagging a bit behind. Let's have a look. So here's the page on JLCPCB's website, and you can see YouTubers on here. Alex Guyver is in first place with 5,598 likes. Who else do we have here? Made in Colombia. SDG Electronics is here. Great Scott, of course. Down here, I think in 9th place, Naomi Wu. Or I might be 11th place. And I'm in, I think, 12th place. So what I'd quite like to do is push myself up the rankings by kind of cheating a little bit. Well, I suppose it's not cheating. I'm sure all these other YouTubers are asking their viewers if they'd click this like button. So what I'll do is I'll put a link in the description below. It'll be the second line in the description. If you click on that, it'll take you to this page. If you could click this like button, that would be awesome. Now I get about probably 5 to 10,000 views on this video. So if everybody goes to this page and clicks the like button, I could get into first place. So what do you think? I mean, if when you get to that, has this switched off? I think it has. If when you get to that page you decide, I'm not your favourite YouTuber and somebody else is, well, that's fine. I can go with that. But yeah, if you'd visit that page, I'd be very grateful. Let's get some of these resistors in. Oh, I'll tell you what. Now, I don't know whether it applies to these resistors. Yes, it does. On Easy EDA, they've added the ability to change the spoke size. I'll show that in a moment. And I'm just wondering if that makes it... Oh, it is a lot easier. So I've reduced the spoke size on these grounded through-plated holes, which ground out into this ground plane, because it was sucking the heat out. And every time I soldered a pad that was spoked out to the ground plane, I had to actually increase the temperature on the iron. But yeah, this is a lot better, and they've added that facility in Easy EDA, which just really helps. And I didn't even ask them to do it. Someone else must have done that. So whoever did that, thank you very much. Okay, that's all the 100k's in. Look at those teeny tiny spokes on those grounded pads. They're really thin. I can't remember what I set them to. I could have a look. And now compare them with an old board where it's got really fat spokes in the middle of that JST connector. This magnifying glass is really dirty, but You can see the really fat spokes there, and that just caused the iron to cool down. Onto 47k resistors, and there are 5 here and 1 there, so that's 6 in total. Let's get those in. Yes, lots of 47k's in here in pairs, so I need 6 of those. I found 2 more 47k's, so that's 8 in total. These are the first 3 going in. Oh yeah, those finer spokes are so much better. I'm not having to boost the iron at all now. So now on to the remaining resistors. 4k7, I think there's 1. There's a couple of 10k's, there's a couple of 220 ohms. I'll just get them all in. So just resistors 25 and 26 to go. They are 8k2 and 1k8. And they do something rather odd. They take the 9 volts from the battery and create the negative supplied to the transconductance op-amp by splitting between 9 volts and 0 volts in this 8k, 1k8 proportion. It's a bit odd. A lot of the circuit is based between 9 volts and 0 volts, but then a middle rail, a sort of 4.5 volts, is created here. I've called it ground, and it's used for the output. And it's split with a couple of 10k resistors, but then the transconductance op-amp is split again. It's a strange arrangement. Also, there's no buffering on the output of the transconductance op-amp. And that's odd because these things have a very high impedance. So that's going straight to the output. So that's going to rely on the amplifier having a very high input impedance. Well, most do. It's a rather unconventional arrangement. Well, now all my resistors are in, and as I say, there are quite a few of them. Now I think there are only 3 capacitors, 1 NPN transistor. The original circuit had a BC182. I've switched it for a 2N3904. It should work. We've got 4 trimmer pots here to set the various sort of decay, pitch, whatever. One of them's volume, of course. But I think I'm going to put the ICs in next. So I just want lots of single row turned pin socket arrays. Right, I need a couple of 4-way. Actually, I need 4 of those because there are 2 8-pin chips, the 741 and the CA3080. And then I need a 7. Oh, I've kind of... Actually, I might be able to get away with that. And another 7, 3 and 4. That just means... Oh. I think I'll break off the 2-pin on the end. Good. And because I wasn't sure if I had some LM324s, I placed an order with a UK seller. Mini integral post bag there. LM324. So I'm going to shove one of these into the 2 socket arrays so that they don't wobble around while I solder them. Bend the legs straight. Oh, I've slightly overdone that. Yes, they've gone very far in. I might just tweak them out a bit. Push that into the 2 pin rows. This one's slightly distorted now because I made a hash of bending that. Oh, that really doesn't want to go in, does it? Come on, in you go. That last pin just isn't quite lined up. There we are. Push that in. And then I can just hold that while I solder a couple of pins. I'll need 3 hands for this, which is fine. Yeah, that's good enough. Get a couple of pins in. Oh, that's cooled down. Wait for that to warm up and get a couple of pins in. I'll use the diagonally opposite corner pins and then solder the remainder. Now let's just check. A lot of chips have VCC on the top row, but curiously the quad op amps have the negative voltage on the top row and the positive on the bottom. So center pin on the top, turn it round, and I don't know whether you can see that, but that is a spoked pad. So yeah, that goes to 0 volts. So that looks correct. Next is a 2N3904 transistor. Let's just check that's an 04. And I've used the Easy EDA standard pad for that, which has it sitting flat on the board with these very close together pads. I'm not entirely sure that's my favourite footprint, but at least that sits very low profile. Let's get that one in. Now I'll just check that for solder bridges between the pads, because they are very close together, but that looks okay to me. Right, capacitors. This one takes the pulse from the piezo and stores it and then lets it decay. Well, because it's got a decay pot on it, the value is not hypercritical, so I'm going to use the 3 mic 3 because I've got lots of tantalums. 1N, that's timing for the oscillator, doo, that sort of thing. 47 mic is on the split rail power supply, so that's just providing, I don't know, stabilization for the ground line. And there's a 4N7 there, which is it's on the output to ground, so it's kind of, I think, a low pass filter that's going to filter out high frequencies. So yes, I'll find a 4N7 for that. So for the 2 little ceramic capacitors, I picked 0.1 inch footprints, and if I thought all my capacitors are 0.2 inch footprints, so I'm just going to have to bend it, and it's not going to look terribly pretty. 1N, what's that? 102, isn't it? There's a 102, and 4N7 is 472. There they are. What do we have left then? Just 3 2-pin DuPont headers, and we've got the 4 trimmer pots, of course, so I'll get those in next. And there is the completed Syntom drum synth with all the correct components, I hope. Now we need to test it, see if it works. Now I'm pretty sure I've got a 9 volt to DuPont connector somewhere. I have to dig that out. The output, I think I can rig something up to one of those 3.5mm headphone sockets. And the input needs to have a piezo disc on it, so I've got to see if I've got one of those somewhere. I'll have a bit of a tidy up and I'll do a bit of searching, and we'll get this thing hooked up to an amplifier. Well, now here's the thing. I couldn't wait, so I hooked up a 9 volt battery, and I've got my speaker on there. I've been adjusting a few pots. One thing I've discovered is that all I need to do is touch the input, because it's got such high gain, it triggers off the mains induced in my fingers. So if I bridge across these 2 connections, and that's just a very silly sound, so let's turn this pot down, which I think speeds up the decay. Let's turn it further. This is the volume, and I've set that to maximum. And now you've got these 2 pots which do the amount by which the tone drops and the general overall frequency, but they kind of interact, which is a bit naughty. Let's try it. That's very high. Let's try this one. Yeah, we do seem to have some very high frequencies. I'd prefer some lower frequencies. So let's go right down on that one. Ah, now that's interesting, because that's taken away all the pitch droop completely. And we're hearing the voltage controlled amplifier gradually close down to take the output down, but no droop. So let's just turn that up a little bit and turn the frequency down. Let's go right down to a sort of bass drum. That's very low, isn't it? I don't want that. Oh, Frequency is far too low. So yeah, interesting. Well, it works, and it does what it's meant to do. It triggers, it decays the amplitude, and it also decays the frequency. It's quite fun, really. Now, there are quite a lot more of these circuits for drum synthesizers. This is what I've got to at the moment. There's a cymbal, which makes cymbal type noises. It's got a sort of metallic tone generator. There's the syn wave, which I think makes swirly sounds, like sounds of the sea. They have noise generators. There's a Syntom 2, which actually has a noise generator. It's just a transistor in Zener mode, which generates analog noise. So you can make more kind of snare drum sounds. There's a Syn clap, which makes those kind of disco hand clap sounds. So there's lots of these things. I think they'd be really fun to build. So I might get on Easy EDA and start laying out some of those other designs. Yeah, this could do with a little bit of a rearrangement of component values, because these pots, to get the really low sounds, they have to be right on the edge of their travel. Otherwise you get these very silly high frequency sounds, and they're not really like drums, are they? But there it is. There's the original Syntom disco drum synthesizer. I'll put a link actually in the description below to Musines, which is a brilliant website where the old music electronics magazines have been catalogued, so you can find the original article for the Syntom. I did contact the current publishers of that magazine numerous times, but couldn't get in touch with them for permission and copyright and stuff like that. But it's 40 years old. Oh, and also, if you would, please do visit the JLCPCB competition website, link below. It's the second line down, and give me a thumbs up. Let's see if we can get me up the rankings. Cheerio.